Hi everyone. In the given problem statement of minimum number of arrows to burst balloon, we are given some spherical balloon trapped into the wall that represented XY plane. The balloons are represented as 2D integer array points where points I is x start to x end denotes the balloon whose horizontal distance or diameter stretches from x start to x end. Let us understand this example. We can have like x and y axis, and out here, let's say, let me add the values from 1, 2, 3, 4, 5, 6, 7, 8. And just for a reference to help you understand or visualize, the first is spanning from 1 and 2. So the first balloon, right? I can give it an example, but let's, instead of balloon, let me just give the values. The second is spanning from 3, 4. The other is spanning from 5, 6. And the other one is spanning from 7 to 8. Now, in order for me to hit all the balloons, the first arrow that I can target, right? It is going to hit this balloon. The second target is going to hit this balloon. The third target, right, is going to hit this balloon. The fourth target is going to hit this balloon. So you require 4 arrows to burst all this balloon. Now let us take this example. Let me draw it back again. And here you'd require just 5. 1, 2, 3, 4, 5. Now for the first one, right, the range is 1 to 2. Then the range is 2 to 3. Then 3, 4, and 4, 5. Now if I take this balloon, right, and both of them would be joining because both of them would have an intersection which is going to match at 2. Similarly, the 3, right, and another would be this one. It is going to have an intersection. So the first arrow, right, the first arrow I can target at index 2. If I add this, or if I trigger an arrow from here, then both of this balloon is going to get bursted. And if I trigger an arrow at index 4, right, then both 3, 4 and 4, 5 balloon is going to get bursted. So you're going to require 2 arrows to burst it up. Now, if just to get taken another example, so the first value, right, is spanning from 1 to 3. So it's going to span from 1 to 3, and the second balloon could be 2 to 4. So if we draw 2 balloons, right, and another balloon, so if I hit the target at this one, right, then both of the balloons are going to get bursted. So we have to understand if there are intersection point between two of the intervals, right. In this case, the distance, we can think them as intervals. So here, right, if they're an intersection point, then we can merge them. So instead of balloon, right, think it as an interval question. So if there is a area if we can merge both of these values, so we can do that. So in that direction, right, we can merge both of the values and form a proper index, form a proper value. So that would be the idea. So now let us jump to the Python solution for this. So the first thing that we're going to do, right, we are going to sort our balloon width or intervals in a sorted order. So points equal to sorted So you're going to use the key and lambda function, and you're going to sort it by the first value. So now we're going to have our I pointer and our count, which is going to count the number of arrows that we're going to require. So initialize at 0. Now while our I less than length of points, while I plus 1 less than length of points, and start of 1 greater than equal to points I plus 1 of 0, we are going to increment I plus equal to 1, and then our count would get increased by 1, and between that, right, we are going to loop through. So I plus equal to 1, and at last we are going to return our count. I hope it works. Let's see. Let me run the code. There is some error. Yeah, I think the small error that I did, right, I forgot to initialize our start value. So start equal to points of I. Let me run it back again. As you could see, the public test case is passed. Let me submit the code. And from the looks of it, right, I think sorting is going to cause in login complexity. Let me check if I did any mistake. And start of 1. Yeah, so here a mistake that I did, right, it's going to get sorted on the second value, not on the first one. So let me submit it back again. And as you could see, it got submitted successfully. Let me run it again. I'm pretty sure the bits value is going to increase. So here, right, the time complexity, the majority is going to take care or is be taken by the sorting that we're going to do. But apart from sorting, right, here the while loop would be big of n. So the time complexity would be n log n plus big of n on those context. So on the average, right, you can take it like big O of log n time complexity. That's all for this video. See you in the next one.